Thank you, everybody, for coming over and giving me your time for the next 45 minutes to 60 minutes. I know after lunch, it's always a difficult thing for me personally also, right? Especially when you've heard of things like Istio in the morning about microservices, and then you get into a topic like this, which is more design-centric and not exactly into nuts and bolts of technology that we as engineers love, right? But hopefully, I'll try to make it as interactive and as interesting for you possible. And towards the end, hopefully get some interesting questions to challenge the thoughts. All right, so let's go ahead quickly. Who am I? Right, that command of ours in Unix is very useful. So I work for a company called Cognizant, one of the sponsors today. I'm based in Switzerland. Been in the company for a long time, and majority part of my career, I have worked with financial services industry in the IT space, right? I develop systems, I design systems, and I also work with a lot of our teams to help them design systems. So that's my day in, day out work, and in part of that, I also get an opportunity to engineer and implement systems. So that's my life day in, day out. And this topic of domain-driven design and event-centric systems or reactive systems, whatever name we may call it, is something that's been pretty close to me for many years now. I started liking the work around domain-driven design somewhere close to 2005, and since then, I've been following this methodology a while. That's why I feel very close to this topic and want to talk about it whenever I get an opportunity. All right, so what are we going to talk about today? I'll basically go through three phases. I'll set up the context so that all of us are on the same page before we jump into the whole topic of how DDD and reactive systems thing work. And then we'll get into the meat, get to know what are those things that will help, especially when it comes to domain-driven design and reactive systems design methods. And finally, I'll share with you some scenarios, some cases where we have implemented this and what we have learned, right? And then, of course, hopefully we'll get some interesting deliberations through questions. So let's go ahead. The case. Number of us have done service-oriented architecture for a while. We have done, in my earlier life, I've done Corba. So it's nothing new. But what has changed is suddenly this shift, which has happened over the last 3 years or so, gradually, on the cloud-native world, right? We are building systems which are by nature reactive because they work in an environment which is distributed and many actors play a part there. These are systems which are expected to be self-contained and not always dependent on different kind of services and system resources to work. They are expected to be resilient. So, they are expected to be highly secure, blah, 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 many of the things. And topic about APIs, all of these systems are expected to be programmable. They are used so that they can be plugged into a larger system of systems, which means they are expected to provide a programmable interface. And all of this need to happen while they're running in an environment, either cloud or similar to cloud, virtualized environments, right? And that environment has a big property that everything there is software defined. So you need to deal with even the underlying infrastructure in terms of software. And this has an extremely strong property in two areas when it comes to systems design. One is the way we design systems, the topic of architecture, and second is the technology that's used to implement that architecture. And the first part, all the terms here are well known to all of you. Some of them are called buzzwords these days. Some are really, truly useful, right? If you get into an area around chaos engineering on SREs, some people still believe it's all buzzwords. Only Google can do it. Nobody else is, going to benefit out of it. But those are useful practices. And then there are things like domain-driven design on design side, which have progressed over a long period of time, and now people have started to understand that this really makes sense. On the technology side, that's been the high velocity game. You have every 6 months something substantial coming up. Every week you have something coming up, but every 6 months everything changes because something substantial comes up. Just yesterday I was reading a post on Medium when somebody had written that React is out. Now, something which is simply which was a hot cake last year, so suddenly it's mentioned that React is out, and you need to look at Flutter and other things coming up, right? So, fair enough, technology moves, but so how do you keep pace with both of these things, and how do you build systems? It's a bit of a bumpy ride. That's why I mentioned here. People have experiences with it. We've tried to do it in a number of projects, but still it's smoothing out. We are trying to learn, and we are getting to learn what works, what doesn't work. So these four elements when we observe systems development, when me and my colleagues build systems for our clients, are almost everywhere these days, right? Nothing new to you. All four things are prevalent in most of the cloud-native systems. These are being aspired to be built using microservices style, and that's why then I was careful in say aspire to. Not everybody is building microservices the right way. Everybody aspires to build it in a microservices style. They want to offer APIs so that others can consume their systems. These are being built and delivered using DevOps practices, and more often than not, they are dealing with data which is changing, is of different variety, of different formats, the underlying structures, construct, the way it gets exchanged, that is different. So you're dealing with polyglot data a lot. So these four realities are something that we are observing almost everywhere when it comes to building cloud-native systems. And that itself is pivoted around the concept of microservices architecture, the poster child among all four, right? But being an old-timer into service-oriented architecture and other topics, and I think many people have talked about it, but I also fundamentally believe there's nothing about services here, right? And nothing about this size thing, micro. Many people have spoken about it, but probably it's most important to rephrase the term again. Yes, it is microservices term, but there is nothing micro about it, and there's nothing about services. It's about something else. What is it about? It's about balancing two claims that everybody wants to have, two aspirations that everybody wants to have, all our stakeholders for whom we build systems. Either they want us to deliver software at a ever-increasing pace, right? That's the area around speed of change is extremely important for people. How soon can you get this thing into production? And earlier we have given an answer, well, it'll take another 3 months because I need to change X, Y, Z and here, and probably my infrastructure is not going to be ready. On the other hand, especially in enterprise context, I mean, that's the background where I come from for a lot of my work, is the whole area around, don't touch anything. Things need to run. And especially in financial services industry where I've spent a lot of time, people don't want to touch things which are running financial transactions. So production stability, running systems are extremely critical. So there's this duality conflict between these two things. Do I run at a faster speed, or I just ensure what's running keeps on running? That's where the real value starts to come in. And as long as you can satisfy these two things, then only you can claim that you're doing microservices right. So if you just rephrase a little bit what microservices are supposed to do, that's an opinion from my side, but probably anybody who has done service-oriented architecture and distributed systems development would probably concur with that. It's not about services, as I said earlier, it's about building systems which have three distinct properties. One, they are modular by nature, whether you're talking about design time modularity or runtime modularity. There's a lot of focus on microservices around runtime modularity, deployment modularity, having modularity at runtime when they are getting executed, they are being accessed, they are being changed. Second element, and that's where service orientation comes into picture, they are still service-oriented systems in nature. These are expected to deliver you services which allow you to consume what they have to offer, capabilities, right? They have certain capabilities. If you write a pricing engine, you are offering a capability to calculate price of something. You still offer that as a service, and service by definition has contracts associated with that. The third element is resiliency. You expect that you will be able to rely on these systems. So if you can do these three things, and the most important element which brings the focus on microservices, you can do all three at scale. That's where microservices become important. And there are many ways to do it, but microservices is suggesting one of the better ways to do it if you want to achieve these three properties. Build modular systems, which are service-oriented, which are resilient at scale when these are scaled. The only problem is this is not a free lunch. There are baggages that come with it. And there are three major concerns that get activated as soon as you start implementing this design. The first one is complexity. Complexity of design itself and the operational complexity. Often talked about is operational complexity, but there's also complexity in terms of the way design evolves and the way you change systems. The second element is of dependencies. As you build these systems which are distributed, more isolated, more autonomous, there are going to be dependencies between systems, and that's a complexity that needs to be handled separately. And the third element is, I think even in the morning, both Istio talks kind of focus on this, systems will fail, and you will need to handle it. And we've all focused focused on quality of service attributes for a long period of time, but if there's one element which is gaining like maximum traction right now when it comes to microservices, it's resiliency and failure handling. That's why this is kind of the prime property when it comes to quality of service elements. And this, if you consider this to be the intent that you want to build microservices, what kind of benefits can we see? Three major areas: the way we design systems, the way we test and deploy these systems, and finally, the way we actually run them in production. So there are obvious benefits. You get, from a design perspective, as an architect, I get a lot of freedom in terms of composing systems, right? Composable systems, whether it is in terms of composing end user interactions or being able to consume different capabilities to offer newer capabilities, or being able to replace independently and depending on what kind of changes I want to bring in. On the systems architecture side, I get a lot of benefit in terms of scaling and resiliency. And when it comes to testing and deployment, there also I get benefit. The only problem is that there are three other things which I've kind of highlighted where things are a little difficult or become a lot more difficult for developers. Microservices are simpler to understand, extremely difficult to design correctly, right? Everybody can design microservices, that's not a problem. To design it correctly, it's a hard problem, it's not easy. Second, testing and debugging is still a challenge. People are using tools to do certain kinds of testing and debugging. Observability has come in, you have tracing coming in, you have newer testing tools coming up which allow you to do this kind of testing, but it's still a big challenge, especially when you use the word that I used earlier, at scale, right? You can do independently, but at scale is still a problem. And last but not the least, when you actually deploy it into production, operationally, it's not an easy system to run right now, host and operate, especially, again, coming back to enterprise context. Because if you have a lot of legacy and you have a lot of your workforce which used to be experienced in operating an environment of existing technology and older technology, it's a big change for them to run a system like that and operate systems management and monitoring especially. Another thing that we observed, a couple of my colleagues and me, we just wrote a paper on this based on number of projects that we have done on microservices architecture. There are things that we observed, which we have mentioned as obvious pitfalls we have seen our clients falling into. The first of that has been the granularity. How do I decide what is my microservice representing? And that's a big problem. Second problem, again, linked to the whole REST idea. If you build RESTful services, you are doing microservices. It's probably the 90% case whenever we talk to people, yeah, I'm doing microservices, I have XYZ REST services already developed. To pick another one, not going through everything, but technology centricity. Technology is probably one of the most important elements as we are moving forward in this world, microservices or serverless going forward. But the problem is, if you are doing microservices and only thinking about technology and nothing else, we are seeing that people are not getting any benefit out of microservices implementation. And obviously, due to these pitfalls and the way people are implementing microservices, there are challenges that you are facing. You can see in all areas, right? Design, the way resiliency works out. We recently experienced downtime for one of the systems where the problem was not in the system itself, but one of the dependent services, and the developers actually forgot to put a timeout on invocation of that system. It was a simple technical issue, but caused the entire system to go down. That has been a obvious case. And then there are other areas around observability and one area which I would like to focus a lot on, especially coming again from enterprise space, is the people angle. We all have got excited about microservices. We all read about it. We see certain tutorials. We go to some GitHub repositories, try it out, and suddenly we have a lot of people as certified Microsoft experts, microservices experts, or they know microservices and they start building REST services. That's an observation that we have made. And then, unfortunately, that doesn't give you much of a benefit. So scaling this whole work through people is a big issue that we are seeing. People is one major challenge that people still have to solve. And there are two parts to it. One is the new developer community, which gets really excited just by technology. And then there is a community which has developed software in companies for a long time. Changing their mindset to this approach is a second element where people are finding a lot of challenges. So in order to overcome this, technology alone is not a solution. And we have seen, unless you combine all three things, how architecture works with your organization. A number of us have heard about Conway's law, right? Your architecture kind of represents your organization. So unless you deal with that problem, it's not going to help you. The second element, unless your technology and architecture work in a manner that you support polyglot thinking, this is again going to cause problems. And the third element is the intersection of organization and technology itself, where culture plays a big role. Practice is being supported by DevOps movements, by SREs, the whole of the practice area, continuous delivery. That's what needs to be thought about if you want to see success in that space. So it's not something that if you've picked up a particular microservices framework or a particular middleware which starts to support microservices from tomorrow, or you've picked up Kafka now so that you can do eventing, then you can be successful with microservices. You will need to deal with all three cases if you really want to be successful. And with that, I'll go into the meat of my story, which is how these two things, domain-driven design and reactive systems paradigm, help you deal with these kind of issues. I can't see people around, but people already aware of domain-driven design? Just a show of hands. Okay, good, quite. So bear with me for a while, but let's see how it goes. So I talked about three major challenges we have, right? Complexity, dependency, and failure or quality of systems. If you want to address three of these, that's how I see each of these panning out. So the Bluebook, something which got me excited into domain-driven design early on by Eric, is something where domain-driven design tries to help you with dealing with complexity. If you want to handle complexity element, that's one way that you can take a structured approach towards complexity. If you want to look at dependency management, some of the work that's been done by Mark and a lot of community after that, which is inspired by promise theory, is one way to look at things, and it gives you a lot of insights into how to handle this element. And the third element is Reactive Manifesto, which talks about how to build systems which deliver the kind of high quality we expect on distributed systems or internet scale system. And that's the resiliency element, as I said earlier. That's like the primary property these days. So we'll quickly go into one of these now. So complexity, right? As I said, domain-driven design helps here, but complexity has only two elements. The way it is organized into your IT systems or in your teams, or the way you look at your source code up to the last level, even the way you package your software, the way you package your source code. Everything essentially, it gives you a picture of how complex something is. And the second element that is that you have dependencies between different pieces. Now, if I pick up any of the pictures from architecture diagrams or one of the code visualization tools that we all have been using, it's the same problem. It's just that how do you identify how things are organized, what piece represents what, and how are they connected to other things, right? It's the same problem that was there in earlier parts of the work that we did, whether it was CORBA or service-oriented architecture or three-tier architecture, any of this. The landscapes always look like this. So the problem has not gone away. It's just that it's manifested in a different manner right now when you do microservices. So this probably is known to the team, but essentially domain-driven design, given its focus on balancing both strategic and tactical design elements and bringing in element that architecture evolves over a period of time. So align or evolve it over a period of time is one way to look at complexity, and how I'll just get into it, right? The first element, bounded context. People who know domain-driven design know it pretty well, but why I'm talking about it, right? Here is an example you see from one of the projects that we had. It's a lending solution, as you can see, has different elements. The loans get originated, people request loan, they get processed, then loans get serviced, and then as a result of it, the financing has to work out, the closing has to happen, and during all of this, there are also lending-related products which are created, or the management of these products has to happen. If you look at this whole area of lending, one may think that I look at how the business of lending works. It's organized into subparts, and I'll organize around it. But the experience tells us, the work that we have done, that looking at business organization is not exactly a good way to look at it. Instead, what you can look at is the way operations happen, the way operating model works for that business. So lending business may be structured in a certain sense in terms of the lending products that they have, but the way they operate may be completely different. And the reason for that distinction is because the change origination, the way change will come into this system, the way you will be expected to evolve those systems over time, will be triggered more or less by the operating model, not by the way the business of lending is organized or different products that you have. In some cases that may be true, but in a lot of the cases, our experience tells that operating model is one is better when it comes to aligning your design of bounded context rather than the design of that business area itself. So what you do is you define these bounded contexts, which are essentially in a very simple space, your boundary where things are understood in a common way, I mean, in a very simple sense. And then what you do is you identify in that operating construct, what are the capabilities that you are going to offer. And each of that is essentially a candidate for your microservices. This is something which's been practiced quite a lot. We also, in our experience, have seen that that approach works well. The third element there is context mapping, which essentially leads you to the element of dependency. So none of the bounded contexts will live on their own. They need to interact with other bounded contexts. And when they connect to other bounded contexts, when they interact with capabilities in other bounded contexts, they need to interact, they need to communicate, they need to exchange data, they need to offer their services to other parties so that they can compose. So all those elements need to happen. And these are different ways domain-driven design provides you one structured way of looking at interacting across bounded contexts or across different capabilities. Right? Quickly picking up few of these separate ways, the obvious ones. Two bounded contexts have nothing in common, and the way these models evolve for each these bounded contexts, there's no chance that they will have any common points of interactions, or they will not need each other's services to go forward. In that case, there's no need to look at integrating these two models or trying to identify common grounds or creating common services or shared kernel as we see the other end of the spectrum. In which case, there are two domains or subdomains which seem to have a common agreement on a common model. And the model is both data and functions. And you have to design then the system so that that shared kernel is usable by both. So there are different levels here. At the middle, for example, is anti-corruption layer, which allows both parties to, one, evolve their models on their own, but still manage the integrity between those by providing the capability to translate into each other's model. So this essentially is a choice in a continuum, right? And this is between two choices between how much uniformity you want to achieve and how much independence you want to allow each of the subdomains to work with. And this is important from a microservices perspective because this will ultimately lead to two things. The way, the agility that you achieve in terms of moving forward and implementing certain changes, and also on operational complexity when you actually apply that change. So if you go into one end of spectrum and make everybody go independent completely, that will also lead to a lot of duplication and may not be sufficient and efficient in terms of gaining any common ground between models, and you will keep on isolating and no common use. That's an obvious issue. But if you go on to the other side, other extreme, we are entering into the world of not exactly same, but the whole idea of doing canonical designs, which all of us have seen doesn't work. So the balance is somewhere in the middle, and it's always not one way of doing things. In one of the examples, we have seen that we decided that we will keep an anti-corruption layer between two subdomains. But over a period of time, realized that when the changes were implemented in each of the applications, there was a common ground, there was a common model that was evolving. So we actually refactored out into a shared kernel and used that as part of both of the domains. So that kind of refactoring will continue to happen. So either on one side, it's very, very difficult life. So once the outer strategic design, so to the strategic design of domain-driven design has been taken care of, how do you design inside? Number of these things are well known to all the developers, right? Probably the thing that comes to mind whenever we talk about designing systems, right? We are designing value objects, aggregates, services, repositories, factories. Those are known good old world design pattern stuff. So that's clear. But what's very important is that you don't start with a design picture saying this is my design and that's only going to be there for a next period of time. Instead, I've really seen the idea of emergent design working pretty well. And you don't start with these patterns being implemented. You start with 2 or 3 things which are extremely critical. And these are things such as aggregates. things such as repositories or things such as services and events. So amongst all the things that DDD tells you in terms of internal design of microservices, I've always found these three things to be the most critical when it comes to designing or in parlance we call, low-level design of our systems. Give extreme importance to the way you design your aggregates. These are your transactional boundaries when it comes to your capabilities getting used, your change getting implemented. And aggregate design is probably so important that if that goes wrong, there may not be any value in doing that microservices. So you should give a lot of attention to this, otherwise you'll create a lot of coupling and the change will be hard to manage over a period of time. The second element is around persistence. Hardly any services that we have seen where persistence doesn't become important. But over a period of time, as we have seen technology changing and developer getting independence to use different kind of database technologies, database persistence mechanism. In certain cases, no persistence. You just go on communicating with different services. Persistence ignorance is becoming a lot more important. And their repositories provide you that flexibility to manage the underlying persistence layer changes, whether it is technology-wise or the way you actually persist. The repositories is the second part. And third element is services and event design. And I'll touch a little bit when we go to reactive, but the idea essentially is to bring a lot more loose coupling, and everybody knows that's central to the idea of service-oriented systems. But if you want to achieve it, that's the element you need to pay a lot of attention to on internal designs of your microservices. Because we have seen that in grand designs, people talk, yeah, this will be event-oriented design, but when you look at the internal design of the code, if you're looking at a set of classes that have been written, or the code that has been written across multiple packages, the thinking on loose coupling is not around domain events and services, and either event handling code is spread across the other areas. For example, your entities are handling those kind of things, or in other cases, eventing is being handled by aggregates and other things. So it's something which can go really wrong and cause more trouble than benefits, and then you get a bad name that you told me event-centric systems will be better, but actually that's causing more harm. It's making my code more complex. So these three things are some things you may want to pay attention to. The other element, right, if you looked at complexity, dependency. Now, such a graph, if you look at your source code, you look at your package structure, you look at your application architecture, or you do, observability on your microservices design. If you look at even the picture in the morning, which Alisha was showing, right, on the Kali dashboard, these are nothing but connections across different things. And if we are building systems, they will be connected to each other. And each connection is a contract. And that kind of contract can break. It's a promise, right? So coming again back to the topic of promise theory, every connection is a contract, and I contract in two things. Contract in terms of functional correctness. I expect you to provide me the right price for this instrument. That's functional correctness. But I expect you to provide it within 2 milliseconds. That's quality of service. So the contract will have both the elements, either a functional correctness or quality of service of that correctness, right? So that contract will break due to one reason or another when you're getting into microservices style architectures or any distributed systems where there are moving parts more than one. And what it leads to is that your coupling starts to increase, both in terms of time and space. And whether, if you're not building your systems which are synchronous in nature, that will create a lot of coupling in space. And in terms of this whole mishmash of systems interacting each other, there are going to be issues in terms of ordering of when services invoke what, when the responses come out. There may be systems which may be down, so there will be a lot of coupling even in time in terms of flows getting completed. And this will cause you issue in all three properties that you want to have in distributed system. You want these systems to scale, you want these systems to be resilient, and you want these systems to be autonomous when it comes to changing them over a period of time. So dependency management becomes a lot more critical. And this is where promise theory comes in. Idea is simple, but we have found it to be a difficult thing for a lot of us developers to actually put it in practice. Now, the point that living in past, you have to start thinking in past, is a difficult problem. I'll give you a quick example. It is actually happening right now in my life. So I live in Switzerland now. I came from India 2 years ago, and my contract with the Swiss authorities, my work permit is under renewal right now. So So what they're doing is when they get a request for this renewal, they have to do three things. They have to check with the federal authorities. They have to check with the local authorities there that everything's right. They have to look at my work contract and a couple of other things. Now, the traditional way of thinking is they start a process of work permit authorization, classic workflow launched, and they will invoke each of the systems from federal and other case and get a response back, and then at a point in time, this will get completed. Standard way of thinking, all of us have done it that way. The way things have changed now is that they get a request when it goes to thinking in terms of systems or promises that coming in. They say, I can approve. Now the thinking changes. I'll approve this work permit as long as the federal government, federal offices informs me, approved from their side, local government approved from their side, clear from debt management guys or XYZ, whatever requirements are there. Now that thinking itself is different. As developers, we do not think in that sense. And which means that we traditionally build systems for the first model, invoking things one by one and then coordinating a result and taking it forward. And that's where promise theory provides a lot of guidance that start thinking in that term, right? Thinking in terms of what are those events that would have happened as a result of it, my promises I'll be able to keep. And I'll be able to keep up my promise if XYZ other promises are kept because I'm dependent on that. I can only approve Dinkar Gupta's permit if I get an approval from federal government. I don't need to invoke. I know they'll send me an approval. And that's a different kind of thinking. And then if you have to implement in system, it's a different matter altogether because you need to get into a different paradigm of programming as well as integration. So three elements there. First of all, these four parties, the federal office, the debt office, the local municipality office, and the immigration office, which is going to approve it, they all need to be autonomous. If they are always coupled to carry this out, it's going to be extremely difficult. They should be able to move at their own pace and complete their task independent of each other. That's essentially around autonomy of actors. Now, it doesn't mean you need to implement actor model always, but the autonomous actors is this design that you implement by multiple paradigms in programming. The second level element is, from a promise theory perspective, is around concurrency and modularity, which is essentially an idea about time and space decoupling. And third is the area around failure handling and promises that have been broken. Now, let's say there is an SLA on these guys, for my case, that this needs to be approved in 4 weeks. That's the SLA for them, for every person who works in there. Now, for them to be successful, to be able to keep up that SLA, the promises that they have from other governments, those guys need to ensure that they come back with their promises in that time. The federal government needs to ensure they come back in 1 week. The other guys need to ensure they come back in 3 weeks. So if one of those things doesn't happen, what do? They just keep hanging on to my permit? Or there's an alternative there. So they need to build systems which has this built in, that there will be promises will be broken, which means there will be certain integrations which will not work, or the federal governments may come back with, as we say, imperfect responses. Looks okay to us, but there's an element which is not completely clear. So how do they handle that, right? In the past, even I've been part of many of the designs where we didn't think of all such scenarios when we design systems. Leave aside programming. Programming is a different element. There, we a lot of time forget about different such scenarios. But even in terms of design, we don't think about all the scenarios. And one change that I've started saying that if you have to do microservices right, especially given the whole large distributed systems, that's an element which needs to be paid to a lot of attention. Recently, why this happened, there's a system which was, there's an online banking system which actually, went down. And the reason for that was users were not able to log in. But the people who coded that area where the first set of pages where when you enter the online banking system, did not even think about that the credential management system or the system which allows people to log in will ever go down. So they never thought that promise will be broken by that system. So it was never taken care of. So one day, there were two systems which were integrated. There were two separate channels which were integrated into a single channel, unified channel for clients. This is a real example. And then clients started hitting the system. Now, due to whatever reason, for one set of clients, the login system didn't work. So, classical issues, resource exhaustion. Everybody started hitting the login system. It didn't work, choked, system went down. And the entire online banking went down due to that. And not because of online banking system, but the login system didn't work. So the calls didn't even reach the online banking pages. So the whole system went down. And the problem was that the perception in the market was that banking is down. The guys can't even log into this. You must have seen a lot of these cases, but recently there was a real case where something like this was not handled and caused a lot of trouble to people. And as I said earlier, this was the same case where the issue turned out to be two things: timeouts and the failure that were not handled in that login system. So this brings to the area around events. Okay, so my animation went for a toss. Sorry. So what happens, right? Any system that you build, which is consumed, has three states, as you can say, a mental model, only three states to it. There are consumers who decide to do something, they act on it. As a result, some things happen, and people inquire about that result. That's what happens in any system that you pick up. At the end of it, that's kind of a meta model of what happens. Now, whenever this happens, if you start thinking in terms of events, you have to build a system which can start responding to events in each of the phases. What did the user decide, not what action user take? As part of those workflows, let's say the user is going through certain screens on a channel application or through a CLI application or through API invocation, what actually happened? What decision took place which I need to respond to? And that response is your act. And then when you act on it, that's a processing that you have done on your sphere, on your own microservice, on your own bounded context, let's say, for example, right? As a result of it, certain actions happen which need to be reflected somewhere else, on which people may inquire. And then the whole circle starts. As a result, a lot of events get generated. And this whole cycle of event starts to come in. Whenever this happens, there'll be a lot of events that will be generated. Each of that event would require you to store it. Excuse me. And why would you store it? Of course, there are a lot of users out other than just being used for auditing. These will be stored, these will be distributed because it needs to be processed. And then finally will be processed. And then a lot of those events will also be projected. And the difference being between processing and projecting is, the way I tend to use it is, processing is within your context. You consume those events to actually carry out the action that you were expected to do. But while you did that, there may be other elements of your system, other participants of your system, other cooperating elements, other microservices, other systems, which may be interested in those events and may have to react. Especially if you're, let's say, again, coming from a financial system, if I'm building a banking system and I have partners who need to offer clients certain things. Or just like yesterday, I was talking to some of our colleagues in telecom area. Let's say a new subscriber subscribe to your telecom company's offer, new phone number. And some of your partners need to be informed. Let us know when you have a new subscriber. They will offer certain services. Now, those are not part of your services. So your processing internally is a consumer subscribed. You have to allocate them a number. You have to put them in your system, everything. But there are other people who are interested in those events happening in your system. And that's why I say, right, it's a system of system things. And for them, you may need to project these events. So if you're building reactive systems and if you're building event-oriented system, make sure you are taking care of all of these things in your eventing system. Just having, the problem that I've seen in the past is I have a message bus now, or I have a Kafka and I'm distributing events. That itself is not sufficient. You need to think about these in your designs, and then how are you going to consume it? And if you're doing it right, you get 4 of these benefits. Everything else is obvious, but the last one I wanted to mention, something which we saw in the first session today, that's where tools like Istio are helping a lot. If you have a good stream of events built up, it doesn't just help you in the systems level observability, but also business level observability. You can actually build really nice visualizations to tell what's happening in terms of business events. And somebody coming from an old world may still say that it's nothing but business event monitoring. Yes, it is business event monitoring, but with a difference. The technology element has changed, the paradigm has changed, so you still need to do the same kind of things without having that BEM middleware sitting somewhere, right? So that's an element. And as I said earlier, if you're not asynchronous, you won't be able to achieve the kind of resiliency that you want to have. Okay, but quick one, that's the biggest trouble. And I'll say that again, I said it earlier. This thinking is the biggest change, especially for all of us developers. We do not think in those terms. And this is an area which takes time for us to develop. Last element on this reactive system space, I'm assuming everybody knows Releaseit, Michael's work. This is one thing which I go to every other day whenever I have to deal with these kind of systems. Things will break, and they will break in unknown styles. But there is a set of ways which have been documented where we see things breaking and how you deal with those things. Now, a number of those things have been talked about in the STO session in the morning, so I'm not going to get into details of how it's implemented, because in earlier part, I'm sure all of you have coded some of these in code. We have programmed circuit breakers, we have programmed timeouts and all. These days, the technology around our systems have become intelligent that we get it out of the box, and you don't need to work out how to put in a circuit breaker. It's a matter of configuration now. What is quite important is things like compensation. That requires you to think architecturally. That requires you to think design-wise. To give you another practical example, in one of the cases, certain transactions failed. So the team came back saying, the middleware team, you know what, no problem. It was just 0.03% of transactions which failed. Rest everything went fine. So the problem was okay. From a systems perspective, it was okay, but each of the transaction was worth $5 to $6 million. So that 0.3% is actually a big issue for a bank. So if you don't design what happens if something like this fails, you will have issues. Right? So designing for compensation is an extremely important element. This is not something that you'll get in a framework or in a STO. It will give you an ability to integrate a compensating action that you can get. You can always define what's the fallback option in case I need to do. But what is that compensation? That's a business decision. That's a functional decision. Right? Do you need to credit some money back into somebody's account or give them an offer which is compensating, are two different things. So this is another element which needs to be taken care of. Now, all of this has been really coded as of today, if I may say. Most of the frameworks you see provide you this out of the box, the 4 major elements of Reactive Manifesto, and you don't need to code all of these on your own. One of the benefits where technology is really helping microservices design is a lot of this is now built into the plumbing. The frameworks, whether you're going to Kubernetes infrastructure, whether you're going to a Kafka infrastructure, or you're going to an STO, or for that matter, getting into the managed platforms like Pivotal Cloud Foundry. These things people know every other system that you build in microservices style will require. So they have built it into the platform instead of waiting for you to program. So that's something that you can reuse. Now, quickly going into some examples. This is an example of a lending system that we built for a client. And if you see the way we discussed and then thought about and then agreed with business, the domain decomposition or the bounded context definition was aligned to the way they had products. They were operating as product teams. They operated, they changed, they evaluated, and they executed and rolled out in the market products. There was no separate operating model other than products. So this is one example. The other one, this was a retail bank where there was no clear distinction as such. They didn't want to look at just operating model or just a business structure. For example, I offer loans, I offer accounts, I offer payments, but it was a mix of things. And then the third one, which we recently worked on, was benchmark calculations for financial industry. So you calculate benchmark rates, and those benchmark rates are used by banks in interbank lending. And here, the design of microservices were aligned to the way the functions used to work, the process of calculating those benchmarks used to work, because we first designed it using the product structure, which means each of the benchmark was its own context and then also the services. But then slowly we realized that that's not how it's going to work, because the changes that were coming in the functionality that we had to build, it was orthogonal. So instead, we decided that we will get into the way process works and aligned our services definition and domain design in line with the process structure. So you had processes like submission process. There is a whole long process of how the banks submit data to these groups, and then how it is calculated, and finally how it is published. That was a much more natural fit to that domain versus the first example where the fit was more about products, not the processes. To give you a quick idea, how does it look in practice? Another thing, we don't have enough time today, but a lot of people keep talking serverless versus microservices. This is a microservices system implemented as a serverless system on AWS. So all of these microservices are implemented as functions on AWS. So they have been designed, they have been containerized, they have been integrated, following both the domain-driven design and reactive systems work. But their physical implementation is in terms of functions, which means the way they are deployed, the way their resource management works, the way their runtime deployment works, operations work, is heavily influenced by the function as a service paradigm. So the reason I wanted to bring it is a lot of times, even on internet, we have seen people fighting, serverless will kill microservices. These are not for each other to be killed, right? They're complementary. You can use them together. All right, so quickly, I'm not sure if it is open to all of you, but we built a reference implementation where, if developers who are new to this style, they want to start, all of these things have been applied there as reference implementation code and designs, and you can take a look. It's on GitHub. One of my colleagues has it. All right, so what have we learned quickly, right? First part is this, and this is probably something which we get to see a lot, right? Some of our clients get too excited going to a conference or meeting some of the consultants, and they're like, hey, can you change my system to microservices? And what you have is a 30-year-old mainframe system running, or a COTS product running somewhere. So the thing that we have realized is that you need to look at two dimensions if you want to think about adopting microservices. How much differentiation are you really trying to make in the business? And how volatile that journey is going to be, or evolution going to be. If you are not one on the top row and not more towards the right-hand side, think twice before adopting microservices, because the complexity that comes with it may not give you the kind of benefit that you're seeking. If you are building something which is the differentiation is pretty low, you're building something which is commonality across all your company that's of your type, and it doesn't change that often, please do not spend your business's money on building microservices. Go ahead in the market, buy a COTS product, deploy it, or go for a SaaS solution. So it becomes extremely critical what you're trying to do, whether you're trying to build something which is going to be a little bit differentiated from a company perspective, but going to remain stable, or you're building transformational as we see on the right-hand side on the top. So accordingly, you can decide whether you really want to invest in adopting microservices, or you're better off using other styles which are there. The second element, and this is more about the language, right? DevOps did one great thing about developing software. I mean, if I leave everything else aside, at least allows people to talk the same language. Not everywhere, but it has started to help. I see DDD helping in the similar way. Right? It will force you to collaborate with your business to start to speak the same language if you have to do that kind of work. It will bring you to a position where you think that design will evolve over a period of time, so I need to be okay with that. And it will help your team build up stronger business and domain skills. I think that's another important element. So you better pay close attention as developers and managers of engineering teams to build around that thing. The third element, and this is a part which is like the difficult part which I've seen happening. All of those four things are the difficult part of adopting microservices. And if you pay close attention to these four, you may be able to get onto the journey better instead of ignoring those or not giving them enough attention. And last but not the least, don't just look at technology. There are other things you need to learn if you have to be successful with microservices. How you architect systems, right? So the advice that evolutionary architecture gives, what Neil Ford and team have given, is quite nice in terms of combining different design styles to actually do microservices well. So that will be one way of looking at things. How you deliver software. So the work that's been suggested in Accelerate, the state of DevOps reports, based on that, the whole work has been done. How they've combined continuous delivery and the lean engineering, lean product management product practices together. How you handle failures, not just in technology, but as a team. Excellent piece. You need to learn that if you are doing if you have to do microservices well. And finally, don't try to create another, and I've seen some of the clients create a 12 months program. After these 12 months, we will be building cloud native systems because we'll be mature towards it. We would have built whatever is required. It's a journey which will be incremental in nature. So build that kind of habit in your team. Improve your teams one bit at a time, in certain practices first and then in other practices first. So if you have to do successful with microservices, technology will probably be your last problem. You may have to deal with all four of these first if you want to be successful. And with that, I'll leave you with this parting thoughts for questions. I really love this quote from Donela's book, that there are no single system, right? There is nothing called single. It's a system of system, a lot of things working together. It's important what you're talking about when you're talking about a change or a certain implementation. It's very important where do you define the boundary. And that's why domain and context are extremely critical before you start talking about a technical implementation. So with that, thank you. I'll open it for questions.